All right, this video is intended to help you understand what standard form of a linear equation is. We've already studied and are familiar with slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Also point-slope form, y minus y1 equal to m times x minus x1, where you can start a graph or start an equation at x1, y1, and again, given the slope. Standard form is much more general form. It's ax plus by equals c, where a, b, and c are integers. So again, positive or negative whole numbers, but integers, but don't actually stand for much of anything. They're not like the slope or the y-intercept in these other equations. Ax plus by equals c, those three letters don't really get you directly anywhere, but they are fairly helpful, especially in many word problems. Now, in order to write a standard form equation, basically, if you start with a different form, such as y equals mx plus b up here at the left, all we need to do is convert so that x and y are on the same side of the equation, and also so that a, b, and c, again, are integers. So the first thing that we want to do is eliminate the fractions. That's one option. So if I see a 2/5 in my equation, it's a great time to multiply on both the left and right sides of my equation by 5. So that if I distribute that 5 times 2/5 is 2, and 5 times -3 is 15. I've got a slightly different looking equation, but again, perfectly equivalent and no more fractions. The only thing left to do after that, again, is get x and y on the same side. As long as I want to leave the -15 on the right, I'm going to go ahead and subtract my 2x over to the left, and now I'm in standard form. It does not matter if your coefficients are negative or which coefficients are negative. It's perfectly fine to have any one of the three come up negative. Same deal happens over here. Those two steps, essentially eliminating the fractions and getting the x, y on the same side, can be done out of order as well. Notice here I've got my x on this side. I'd love to have it over on the right side with the y. So the first thing I'm going to do is add my 5x to the other side. Now would be a great time to get rid of that 1/2. So I'm going to multiply on both sides by 2, again distributing on the right side. And then finally, since x and y are sort of on the right, and I'd love to have it look like the form on the bottom of the screen, I'm going to go ahead and mix it around a little bit. 10x plus y, using the commutative property, would be equal to 22. And now I've got a nice looking standard form equation. Now, more than just writing a standard form equation, sometimes we have to come up with it given certain amounts of information. So given a point and a slope, a great time to start a point-slope equation or search out a slope-intercept equation, I want to get all the way to standard form. And we're going to do that by actually going through all of the other forms. Option number 1 is to start with a point-slope equation. So taking my x1 and my y1 and my slope, I can write that point-slope equation. Then, simplifying, I can distribute that -2 and move my -3 to the right side, making a slope-intercept equation. Now again, another option to get to that point, I could take my point, plug it in for both x and y, and my slope plugging in for m, and I could start directly with mx plus b, y equals mx plus b. So again, y being 3, x being -4, and just go ahead and search out the y-intercept that way. Again, getting me to a slope-intercept equation. Last thing to do then, if I want to get standard form, you'll notice I don't have any fractions, so I don't have to get rid of those, but I'm just going to add my 2x over there to the left side. By adding 2x onto the left side, I now have 2x plus y equals -5, and I've got my standard form equation. Now, standard form works really, really well, but when we have special lines like this vertical line or this red horizontal line, we have to be a little bit careful. The standard form equation where x and y are on the left side together obviously won't work, because the standard form for a horizontal line only contains a y. And again, for a vertical line, it only contains an x. So y equals a number or x equals a number would be considered the standard form for horizontals and verticals. So since the red line has all the points where y equals 2, the standard form for that equation is just y equals 2. The blue line, on the other hand, is vertical. So again, its standard form would be x equals. And since all the values on this line have x equal to 6, our standard form again is x equals 6. Finally, again, standard form is really helpful in many word problems, many daily things that we do. So let's just say you're buying chicken and hamburger for a barbecue. The hamburger costs $2 a pound and the chicken costs $3 a pound. You have only about $30 to spend. First thing we want to realize is we're going to use X to represent our pounds of hamburger and Y our pounds of chicken so that we have our variables. The next thing they want us to do is write an equation that models the amounts of hamburger and chicken that you're going to buy without spending, or assuming that you're going to spend all your money. We're going to make sure we use all $30. Well, if it's $2 per pound, that's much like a slope. So I can say $2 per X per pound of hamburger, and I'm also spending $3 per pound of chicken. So I can quickly set up in standard form 2x plus 3y, the total money I'm spending, and again, that needs to be equal to my $30. But it makes a fairly easy and quick equation to set up. Then if we want to graph it, remember graphing from standard form is really easy. Don't be a chicken. But it's really easy to graph assuming that we use intercepts. I can plug 0 in for 2x, 0 in for x, that is. 2 times 0 just disappears, and essentially 3y will be equal to 30. Or if I set that up for you here, basically you're looking at it and saying, okay, if that disappears, 3y equals 30, y is going to be equal to, y is going to be equal to 10 then. And same thing the other way around. If y were equal to 0, 3 times 0 is 0, basically 2x equals 30. And we find out that x equals 15. So I've got my two intercepts then of 0, 10, and 15, 0. I can plot them on my graph, and this line, this red line, would be the various amounts of hamburger and chicken I could buy and spend $30. If I spent a little bit on hamburger and a little bit more on chicken, again, I could lie anywhere in between my two intercepts. And what do these intercepts really represent? Well, basically, the intercepts of my graph represent whether I bought one kind of meat with no other. So the intercepts assume that you purchased only one type of meat, basically saying, if I didn't purchase any hamburger, I could purchase up to 10 pounds of chicken. If I didn't purchase any chicken, I could have purchased up to 15 pounds of hamburger. And again, that's what those intercepts will be. I hope that understands you, or helps you understand standard form just a little bit better. Good luck, and of course, if you have questions, make sure you find your teacher. Have a great day.